Alright, today we're going to spend some time talking about the metric system and SI units. The metric system is an international decimal-based system of measurement that scientists from around the world have agreed to use. The metric system contains units that are made up of two different parts. The units have base units associated with them, along with prefixes that go out front. The base unit can be expressed in terms of other units by adding the prefix to it. Examples of base units would be things like grams, which is used to measure mass, meters, which is used to measure length, and liters, which is used to measure volume. When we add the prefixes to these base units, we either make it a smaller quantity than the base unit or a larger quantity. Examples of those prefixes can be seen here. Over here on the left-hand side of the screen, we have the prefixes that represent those values that are, or those units that are smaller than our base unit. And over here on this side of the screen, we have the prefixes that represent the units that are larger than the base unit. Some of these should hopefully look somewhat familiar to you guys. For example, centi and milli are probably familiar. You may have heard of nano before. Over here on the larger side, kilo should be familiar, along with, if you're familiar with computers and bytes, mega, giga, and even now tera. So for this class, we will have some units that we will need to know and use throughout the semester. So those units that we need to be aware of are here. So we have centi, which is 10 to the power of negative 2, and is represented with a C. So if we were referring to centimeters, we would put a C in front of the M to represent centi and meters. We would also need to know milli, which is 10 to the power of negative 3, and the letter to use for that would be an M. So again, if we were talking about millimeters, we would put a lowercase m in front of the lowercase m for meters. I also want you guys to know micro, which is 10 to the power of negative 6. We use the Greek letter mu to represent that. And I would like you to know nano, which is 10 to the power of negative 9, represented by a lowercase n. Over here, where we're getting larger than our base unit, the one that we predominantly use is kilo, so 10 to the power of positive 3. Knowing these prefixes and knowing how far away they are from our base unit allows us to easily convert from one unit to another. For example, in this problem, I'm asking you to express 5 micrograms in units of just grams. So if I know how these two are related to each other, I can easily move my decimal a certain number of places in a certain direction to change my value. So, as we saw on the previous screen, micro is 10 to the power of negative 6. So, that means then that 1 microgram is equal to 10 to the power of negative 6 grams. So, if I want to change 5 micrograms, I will need to move my decimal 6 places. And because I'm going from a unit that is a smaller quantity than my base unit, I am going to be moving my decimal to the left. So I start with my 5 micrograms, and I move it 6 places to the left. And I fill each of these values in with 0, which means 5 micrograms is equivalent to 0.00005 grams. If we take a look at this example, we see that we're trying to go from a unit of liters to a unit of milliliters. And looking back at our chart would show us that milliliters are 10 to the power of negative 3 liters present in every 1 liter. So if we're going to convert from liters to milliliters, we will need to move our unit 3 places. But this time, because we're going from something that is a larger unit and going to something that is smaller, and I'm going to be moving my decimal to the right. So I will move it to the right 3 places. And 1.12 then becomes 1,120 milliliters. And finally, in our last example, we're going from units of centimeters to units of kilometers. Going back to our chart, we're going to show us once more that centimeters is 10 to the power of negative 3 meters in every 1 centimeter. And kilometers power of 3 meters in every 1 kilometer. So this time I need to move my decimal first 2 places and then 3 more for a total of 5 places. And because I'm going from something that is a smaller unit to something that is a larger unit, I'll be moving my decimal to the left. So my 7.6 centimeters, when I move my decimal 5 places to the left, becomes 0.0000076 kilometers. So, if you have any questions, things you can do at this point, go back and re-listen and take notes on some of the examples. And if at that point you still have questions, come see me during Tuesday or Thursday in order to get the help that you need. The last thing we're going to talk about today is the International System of Units, also referred to as SI units. SI units are a set of units that the international scientists have all agreed to use that are based on physical standards found within the universe. And if you take a look at this chart here, you can see what they are. When we talk about length, the agreed upon unit of measure would be a meter. When we talk about mass, the agreed upon unit of measure would be kilograms, grams, though sometimes it's also referred to as kilograms. And if we're talking about time, we'd be measuring that in seconds. Temperature would be measured in something like Kelvin, and amount of substance would be measured in something called a mole. Now, when we say that these guys are based upon physical standards found within the universe, if we are talking about what mass is, what a kilogram actually is, there is an actual piece of platinum uranium alloy that is located in France that has been set to have a mass of 1 kilogram, and everybody else bases their standard masses off of that. If we're talking about length, the standard length of a meter has been defined as how long it takes light to travel through a vacuum over a specific amount of time. And so these things all have standards that we can use to help us figure out how big they are. You'll notice that some units are not on this list. For example, volume cannot be seen here. And that's because volume can be derived from other units. For example, if I were to take my